Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I believe this video will be part 6 video of my SolidWorks mist spray fan project. Alright, in this video I would like to show you how we will do part modeling of this fan blade. So this photo is a fan blade of my mist spray fan, portable mist spray fan. So I already make a rough sketch here about the dimension. The number of blades is 7, and overall if I measure the maximum diameter from the end to end of the blade is 65 mm, and we have the inner cylinder here shown in this photo. The cylinder is 26 mm, right, 26 mm, and if you look on the side view is 8. Alright, I roughly measure the because the blade is we have like a curve, and it like twisted, and we have 7 blades. I already measure here the distance from here to it's about 7, and the at the outer edge there the diameter is about 20. Alright, actually there's a lot of ways to do. If you look in the YouTube how they show you how to model the fan blade, but I found out the way that has been shown in the YouTube. They use sweep boss by using twist angle. In my opinion, the result of that fan blade is not that accurate because we cannot control the width of this. We have here fan blade, we have of a curve here. If I measure my fan blade here is 7 mm, and at outer edge there is 20 mm. If you use sweep boss and use twist angle, you cannot control the dimension that you want like this. Okay, my approach is different. So in SolidWorks, make sure the unit is mmgs, right? Okay, depend on how you want your orientation of your fan blade. Okay, if I want my fan blade orientation is standing up, not laying down on the floor, so okay, unit is mmgs. I will go on the front plane. Okay, on the front plane I start the center cylinder first. Okay, as I mentioned to you just now, the diameter is 26, and at the side view the thickness is 8. Right, the thickness is 8, so I will go for 8 mm thickness. So this will be the center cylinder. Alright, my approach is different what you have found from the YouTube, how to create a fan blade, because I think mine is more accurate in terms of controlling the curve of the blade rather by using sweep boss and twist angle. Alright, here before that, since the thickness is 8, I create another plane, because since I will make a fan blade by a thin surface, rather I will do thicken to meet thickness, so I will make the fan blade thickness of the fan blade is not as long, this 8 mm thickness. So I make like little bit is inside. So what I will do, I will create a plane. At the front plane here, I put about 0.5 shifted to inside of that cylinder. Here is going outside, so I go to flip outside, going inside. So I make a plane. So this plane will be the level of for me to create the starting curve of my fan blade. And another plane is here. If I select at the back surface here, so here I will do the same. Put a distance of, hold on. Okay, I make a plane here at the back here. This is my first reference, and it's going to this direction. I make sure it's flip. The distance I set it to 0.5. So we have two planes a little bit start cutting like inside this 8 mm thickness. So this plane 1 will be my level of my first curve. So what I will do here, or this plane 1, I will create a sketch. Okay, this plane 1 I will create sketch. Then here I will create a bigger circle where the level of my 65, since the outer edge the width of the fan blade is 65 mm. So this circle I make it as a construction curve. Okay, what I will create another, since this diameter is 26, I will create another circle here of I put it around 20 mm. So this will be 20 mm, and this one also I set it as a I change it to as a construction curve. Right? Okay, now I will create a center line. So this will be like guideline from this quadrant up to this quadrant. Okay, the idea for me is to get the shape as shown in this photo. We have a curve like this. If you look at the real photo, we have curve like this, but this one is turning to the other side. Right, so what I will do here, okay, at plane 1, so this I will create a spline. I will start at this point, just 2-point spline. I will go like this. Right. Okay, spline, I cannot put angle. If I try to put spline, it's not a straight line. If I put angle from here to here, I cannot put angle. So what I can do for the spline, I want to make this spline like fully defined. So what I can do, I can put the dimension from here to this point. I put some dimension. It's about, if I go for, let's say 5 millimeter. So this will be the point of my spline. So I want to create like, okay, if I show you another photo of the fan blade turning to the other direction, okay, this kind of curve. Okay, if you see here, I want to make the curve like, hold on. I want to make this curve, and at the plane 2 at the back there, I will make the other curves. Now I'm doing the first curve here. Right, so since this is spline, okay, let me find off the dimension. Since spline, we have control handle here, so I make this kind of curve. Right, so this will be my first curve. Okay, still fully defined. Okay, now I exit the spline. Okay, now I go to the plane 2. I make like this, but I turn spacebar, go to that view direction. So I'm now at the back plane, plane 2. I will use these 2 curve here, these 2 circle here as my another guideline. So here I will create another spline from this point to this point. Right, so here is kind of like, if you look, the spline here is, as I mentioned just now in this photo, the 7 is the width. So I will put kind of like from here to here. I can control, like, for example, I want this to be 7 the width. Right, so it will be 7, and here I can control from here to here is 20. This one is 20. So it's wider for that one, right? This is 7, this is 20. Right, now it's fully defined. Okay, now I can play with the handle. I can control the curve like this, as long as I have a shape of a blade for this one. This one is going to be at the back there, right? Okay, okay, this is a curve that I want. Let me adjust a little bit like this, so it kind of, actually I can control it later. So this is a curve that I want. So now I have, if you look here, okay, I have 2 spline, one at the plane 1, and at the back that is at plane 2, right? At the back is at plane 2. Right, so what I will do now is, okay, let me just, okay, let me, okay, create another curve. Let me off. Okay, I want to have a clean view of this plane 1 and plane 2. What I want to do, then I will create, since I have a point here at the end of these 2 splines, so I will create a 3D curve. Now I'm using not on 2D plate. So under the sketch here, I will go for a 3D sketch. So I'm using spline also, 2-point spline, but now my spline is not on 2D plate, it's on 3D space, right? So I will click start at a point and start at a point. So this will be my first spline. I create another 2-point spline, one at a point and second one at a point, right? All right, at the bottom spline, I can control the handle. Since I have the handle, I can control the curvature. So this much better way rather than if you look from YouTube, the way they do fan blade, they use simply a straight line, then use swap, boss, and they have option of twist angle. I don't think so. The result is kind of like accurate to create, because we need kind of like this curve for the fan blade. All right, so I can control the curve. So that's a advantage of doing the way the fan blade that I'm showing you. We have more control how to shape the fan blade. Alright, about this curve also, the top one I can also control the curve. Okay, just be careful about here. If you look at the side view here, about the curve angle, do not make it don't make your curve is flow over the limit here, because our limit is vertical axis like this, as long it's not over like this. So you can make it as long we have time it's not over the limit of this y-axis, right? Okay, here also I can little bit control, right? So we can have the advantage of doing this way. You have an advantage to control the shape of the spline. Another thing, when you look at this front view, make sure that limit of your curve is not over the limit of diameter 65 of the circle, so you can control it like this, right? So this will be my, okay, if I check again my side view here, so I'm not over the limit, so now I have the fan blade. Alright, so this construction curve for me to create a fan blade by using surface. Okay, if you look here, under the surface tab here, hold on. Under the surface tab here, we have lofted surface. Lofted surface, it means we have two profile, and we select two profile through cross section, and we select the guided curve. So I have two cross section here, and the guided curve is here and here. So I'm now under surface. So I go for lofted surface. So the profile, I will select this line. I click OK. The second profile, make sure that balance. First, when you select the first profile, you more on the left side. For the second profile, so you select on the left side. If you select on the right side, it will be twisted when you do loft. Okay. Okay. My second profile, I select at the left side. So I have a preview now. Now I click at the guide curve. I have two guide curve. I select first one and this one. So I have nice fan blade. So I click OK. So now I have this fan blade, right? The shape of this blade. This fan blade is a separate object. Okay, this is a surface body. This is a not solid bodies. The cylinder is a solid body. As you can see, the lofted surface that I create is on surface loft. It's a surface body. Alright, this lofted surface here is still a thin surface. It don't have thickness, so I need to give a thickness. Okay, under the surface here, when you have a surface, you can give a thickness to make it as a solid. So under the surface here, the menu we go for thicken here. So thicken. So the thicken, I don't want it to be. I want it to be so, because the fan blade is so thin. I put it about. So the value for the thicken, I put it 0.2. So it means that very is thin, right? 0.2. If I go for 0.1, I think it's too thin. Let me go for 0.1. So I'm using the. We have an option here. If I go for the left one, it means the thicken, it goes, if I zoom in, it goes to this direction. If I go to the second one, it go to both direction, thicken. If I click like this, so it means it go to the direction. So I go for middle one, so it means I'm using 0.1. So it means the total thickness here is 0.2. So I think 0.1 is good enough. Maybe I can change to 0.2 to make a little bit, okay, like this. So this will be the fan blade. Alright. So okay, here I will not check at merge result. I make it as a separate body, since when I do thicken, this will become a solid bodies. I check the merge result. I make it as a separate solid bodies. Okay, now my surface is no longer surface body, it's become solid body. So I have the thicken, this is a fan blade. I make it as a separate body. Alright, before I do circular pattern, I will do fillet first. Okay, I will fillet at this edge. Okay, be careful what fillet, since here now I'm in solid. I go for features. If I go for fillet, okay, I'm using the first option. If I go for 10 millimeter, because it depends. Okay, if I go for 2 millimeter, so we have this thing. If I go for, I just play around. If I go for 3, I couldn't make it. If I go for 2.7, and if I go for 2.75, if I go for 2.8, cannot, the border is about 2.75, so this would be our limit for us to do the fillet value. Alright, 2.75 here. Right, Okay, for this corner, I can do fillet. Okay, 2, if I go for 3 here, okay, we can, if I go for 4, alright, it depends on how you want the shape of your fan blade. If you look of this fan blade, I don't think so we have really kind of like a big radius, so I remain as I just put it as value of 3, not too much. Alright, okay, I click OK. So this will be my fan blade. Okay, now what I will do, so this is a separate body. Okay, now what I will do, I will make a, I will do circular pattern. So here under linear pattern we have circular pattern. Right, circular pattern. Okay, here the first option here. So this is about our pattern axis. I can use any circular edge here as my direction to do the circular pattern. So, all right. So here I'm not using features. Be careful about it. I'm not using. Uncheck the features because this fan blade is a separate body. Uncheck the features. I go for bodies. Then I select the fan blade. So I can go for, if 5 is 5. So in this case our fan blade is 7. So it's 7. Then I click OK. Alright, this is still separate body. As you can see, we have altogether we have 8 bodies, right? So we have 7 fan blade, right? So I need to join it. Okay, I need to combine it as one, right? So here, okay, I need to features combine. Then I will use add, select this one, and select all the blades, so it become as one body. Now we have one body of blade. So that's a benefit of doing the fan blade like the way I show you, rather than you use sweat boss and you use an option twist angle. You can find it the way they do it in other YouTube. All right. So this is much better. You can control the curve of your fan blade. For example, like I'm not satisfied with this curve, I wanted to make more curve of this fan blade. Sometimes when you do simulation analysis of the airflow, you can play around with the curve. So this one, I can go for my 3D sketch. Either I can change the, for example, like this 3D sketch, I can edit this 3D sketch. When I do my loft, I can play around here. For example, I go for this side view here. I can control the way, the curve that I want. For example, I can play around with the curve like this. All right. So this much better way you can make you do the fan blade, right? Right. So let me go for standard view. Okay, if you look here on the photo here, we have if I show you another photo, we have a cutout. Let me show you another photo. Okay, at the back here we have a cutout. Okay, at the back here we have a cutout. So what I will do at the back here, okay, I cannot use shell, saying when, because this is together with a flame blade. When you do shell, it's kind of SolidWorks kind like cannot calculate. It's kind like maybe it will produce errors. Instead of doing shell, I just make a most basic way. So here I convert entirety. So this is 26. I make this is really thin. It will be offset of 0.5, not 1 millimeter. So I go for 0.5. I select these edges, so not outward, inward, and click OK. So I will do extruded cut. So since the thickness here is 8, I extruded cut of 7 millimeters. So I will do extruded cut. I'm using contours. I select the inner side and I put it 7. So it means I have 1 millimeter left at the front, right? So this is okay. The last thing is about, if you look here, we have a center shaft there. So you have a plane here. So I will create circle. I already measure is about 4 millimeter. 4 millimeter here. 4 millimeter. And I will do extrude. Since the total thickness inside here is 7mm, is about half of it. I will go for 4mm. Later I can adjust it. Depends how this fan blade will be mounted onto the shaft of the DC motor. So I will go for 4mm. Alright, and then I will create a holes. So this is depend on the shaft diameter of the, this will be mounted onto the shaft of the DC motor. So normally the shaft is about 2mm or 1.5mm of the shaft motor. So this one I can adjust this later, right? 1.5mm. Then I will do extruded cut up to surface, right? Up to surface. So up until to surface. So we have a cut through hole, not cut through hole. We have a hole that up until this surface. So this will be mounted onto the shaft of the motor. All right. Let me save this file as okay, fan blade. So that's all I want to show you, how I create the fan blade. The way that I show you the fan blade, the way I do it, I think it's much better in terms of control the curve of the fan blade rather than you use simple twist when you do swept loss, right? So there's a much better way to do the fan blade, right? Okay, thanks for watching this video. Inshallah I will see you in the next video about modeling of the other parts, like for example the mist maker and also the battery casing. Inshallah I will see you in the next video, but before that please do not forget to click subscribe and like my channel. Assalamualaikum warahmatullahi.